Professor of ECE Annex. In this video, we are going to discuss about Programmable Peripheral Interface 8255. In short, it is called as a PPI. This concept is comes under Microprocessor and Interfacing subject. Coming to the contents of today's lecture, I am going to discuss about Introduction to 8255, features of 8255 PPI, block diagram of 8255 PPI, control formats of 8255 PPI, and the different operating modes of 8255 PPI, and how the 8255 is interfaced with 8085 microprocessor with example. Coming to the introduction to 8255, this 8255 is one of the dedicated IC which is designed by the Intel company to interface input-output devices to the microprocessors. Most of the basic microprocessors does not have I/O handling capability. They do not have any on-chip ports. To provide ports to the processor, Intel company designed this 8255. This 8255 is used to interface input-output devices to the microprocessor. Because microprocessors like 8085 and 8086 that do not have any on-chip input-output ports to connect input and output devices. So this interfacing device 8255 can provide three parallel ports named as port A, port B and port C. So here we can say that this 8255 is a versatile general purpose I/O device which is designed for use with the Intel designed microprocessors and most of the other microprocessors also. And it is mainly used in the applications of embedded systems, and it is also used in industrial applications. Coming to the features of 8255, this 8255 is a general purpose programmable input-output interfacing device which is used for parallel data transfer. Yes, this device can be used to transfer data parallelly because all the ports of this 8255 are parallel input-output ports. This 8255 can support three ports named as port A, port B and port C. And as we already discussed, it is compatible with all the Intel and most of the other microprocessors. And this 8255 can also operate in two important modes. One is I/O mode and the BSR mode. In the I/O mode, again it is operating in three modes: mode 0, mode 1 and mode 2. These are some of the features of 8255. Once we go through the internal architecture of 8255, we can understand the working and the importance of this 8255. Coming to the block diagram of 8255, this block diagram consists of one of the main part, that is data bus buffer. This data bus buffer is the main interfacing unit between the microprocessor and the 8255. This data bus buffer is a bidirectional buffer. It has the pins D0 to D7. Through these D0 to D7 lines, microprocessor can be interfaced with this 8255. So whenever the microprocessor wants to interface with this 8255, it sends this D0 to D7 lines to this 8255. And this data bus buffer is also responsible for transferring the data to the output device through any one of these selected ports. And through this data bus buffer, processor can also perform read operation, means processor can read information from the input device. Okay, like that. And this data bus buffer can also be used to send the commands to the 8255. Whenever the microprocessor wants to send some command, some control word to the 8255, that will also be transferred over this D0 to D7 lines. Okay, coming to the read-write control logic. Yes, this read-write control logic is responsible for performing read and write operations which are happened through this D0 to D7 lines. This read-write control logic consists of 6 pins: read bar, write bar, A0, A1, reset and chip select signal. Yes, chip select is one of the important signal that is used to select this entire chip. Yes, all the ICs, this 8255 is an integrated circuit. So in order to perform some operations through this 8255, through this IC, this chip selection must be done. That will be done through this CS bar signal. Okay, this chip selection will be done through the decoding logic. The logic which is used to select the chip is nothing but a decoding logic that will be done through the decoding logic circuit. We'll see about this decoding logic circuit later. Let us see the read and write bar control signals. Yes, these are the two active low signals. Through this, processor can perform read and write operations through the input and output devices. Whenever the processor has to perform read operation, means processor has to read something from the input device, it has to connect that IO read or memory read signals to this read bar signal. Okay, whenever the processor is identified the input device with the IO mapped IO, the processor uses two modes whenever it has to interface the input output devices to it. It reads the input output device in two modes. One is IO mapped IO mode, another one is memory mapped IO mode. In the IO mapped IO mode, processor identifies the IO device, whatever it is connected through this 8255. It identifies that device using IO address. IO address is nothing but a 8-bit address or 16-bit address. 8086 has 2 power 16 ports. These 2 power 16 ports are addressed with 16-bit address, and it is also having 256 means 2 power 8 8-bit IO ports. So whenever a processor can identify the ports with 8-bit or 16-bit, okay, those ports are interfaced through the IO mapped IO mode. And also microprocessor can interface the input output devices through the memory mapped IO mode also. During the memory mapped IO mode, processor uses 20-bit address as like it is identifying the memory, it identifies that IO device. So like that the processor selects either IO read command or memory read command to select the IO device to perform read and write operations. So for read it sends read bar signal, for write it is sending either IO write signal or memory write signal. Like how it is identifying that IO device means the address which is used to identify that IO device, it sends the respective signals. IO read, IO write, memory read and memory write. And coming to the A0 and A1 lines, yes, these are the two important address bits that are used to select ports. When the 8086 is interfaced with this 8086, when the 8086 is interfaced with this 8255, it sends two lines, that is A2 and A1. A1 is connected to this A0 line and A2 is connected to this A1 line. Okay? If A2 and A1 are 0, 0, means these two are 0, 0, port A will be selected. When it is 0, 1, port B is selected. When it is 1, 0, port C will be selected. When it is 1, 1, control word register is selected. So we are talking about the 8086 interfacing with 8255. So I am explaining that what are the address lines that are connected to this 8255 in order to select the ports. Yes, there are three ports, port A, port B and the port C. Okay. In order to select these ports, processor has to send address on these lines A0 and A1. Here, when 8086 is interfacing with 8255, A1 and A2 address lines are connected with A1 and A0 lines of this 8255. When these two are 0, 0, port A will be selected for operation. When these two are 0, 1, port B will be selected for operation. When these two are 1, 0, port C will be selected for operation. When these two are 1, 1, yes, it is very important. Control word register is selected for operation. Control word register. Yes, the register which is having the control word. Control word is the word that will be sent by the processor in order to configure these ports. How these ports are needed to, how these ports are need to operate. Like whether the ports will be input ports or output ports. Yes, all the ports are bidirectional ports. In order to use the respective ports as input ports or output ports, that command will be entered into the control word register. So this control word register will be selected when this A0 and A1 address lines are 1-1. Okay, we'll see about the control word later. Coming to the reset. Yes, reset is used to reset all the ports and the control word register of 8255. Reset out signal of microprocessor will be connected to this reset signal. Coming to the ports, 8255 has 3 ports, port A, port B and the port C. All these ports are 8-bit ports. Individually, all the 3 ports, port A, B, C are operated as 8-bit parallel I/O ports. 8-bit parallel I/O. At a time, they can be used to send 8-bit data and can be used to send receive 8-bit data. Among these 3 ports, port C can be used as 2 4-bit ports. Port C upper and port C lower. Okay, port C upper can be represented as PC4 to PC7 and port C lower can be used to represent as PC0 to PC3. Like port A lines can be represented as PA0 to PA7 and port B lines can be used to represent as PB0 to PB7 lines. In order to control these ports, there are 2 group controls, Group A and Group B. Group A is used to control the port A and port C upper. Group B is used to control port C lower and port B. Each control can control 12 pins. Okay. Coming to the operating modes of 8255. 8255 can be operated in 2 modes. One is I/O mode, another one is BSR mode. Under the I/O mode, again it is operating. Under the I/O mode, again it is operating 3 modes. One is mode 0, mode 1 and mode 2. Mode 0 is nothing but a simple I/O mode. In the mode 0, all the 3 ports are simply acts as input or output ports. They can be used to receive data or can be used to send data. That's it. No other function. In mode 1 is also called as handshaking I/O mode. Handshaking I/O mode. Yes. This mode of operation will be based on the handshaking signals. Yes, handshaking signals are the signals which are used to control the data transfer, which are used to provide the mutual understanding to exchange the information between the 8086 as well as the input-output devices. And these handshaking signals are used to control the operation. In the mode 1, port A and port B are operated as input-output ports and port C is used to provide handshaking signals. Okay? In mode 0, all the 3 ports are operated as input-output ports. A, B, C, all the 3 ports are operated as input-output ports. In mode 1, only port A and port B are operated as input-output ports. Port C is used to provide handshaking signals. Let us see what is this handshaking. So, for example, we have a microprocessor and we have a printer. Okay. For example, we have a high-speed microprocessor. Printer is of low speed compared to this microprocessor. For example, if the microprocessor sends data to print, okay, printer may not accept that high-speed data because both are not compatible. So, before sending the data to the printer, if the processor sends one signal to ask the printer that whether you are able to print this high speed data or not. If the printer is able to accept that speed, then the printer sends a signal which is nothing but the acknowledgement signal. Then the processor initiates the operation, that is, it is transferring the data. These two signals here are nothing but a handshaking signals. These signals are used for helping the exchanging of data between the printer and the microprocessor. These two signals are used to help the data transfer. These signals are nothing but a handshaking signals. So like that, whenever the processor is interfacing with the printer with the input-output devices, this 8255 will be used so that the reliability of operation is there. Otherwise, the unreliability is happening. There is no guarantee that the data is perfectly received or the data may be perfectly transferred to the output device. So, to increase the reliability in operation, 8255 is used, and among the three modes, this IO handshaking mode is also used. That is handshaking with IO. Mostly 8086 when it is interfacing with 8255, this mode of operation will be used. Okay, coming to the mode 2. Mode 2 is nothing but a bidirectional IO with handshake. Yes, the bidirectional data transfer is happening. Okay, in this mode 2, 8255 is operated in bidirectional IO with handshake. In this, only port A is used for bidirectional data. Okay, only port A is used for bidirectional data. Means port A is the only port that is used to receive data or transmit data to the input or output devices. Port B does not have this capability, means port B is not used in mode 2. To provide the handshaking signals, here port C signals will be used. To provide handshaking signals for this data transfer, the signals from port C will be used to provide that handshaking. Means port C signals are used as control signals. Okay. In mode 0, all the ports are input-output ports. In mode 1, port A and port B are input-output ports, and port C lines are used to provide the control signals. Okay, and in mode 2, only port A is used as IO mode, and the port C signals are used as control signals, like the strobe, acknowledgement, or it is saying, for example, if the data is received by the input device by the 8255, then the 8255 will be sending the processor that the input buffer is full. Then the processor is getting interrupted, and then it initiates the read bar signal to receive the data from the 8255 buffer. Like that, the control signals are used to helping the data transfer. Coming to the control word of 8255. Yes, these three modes, mode 0, mode 1, mode 2, are under the control, under the IO modes of 8255. So in the IO mode, we can operate the 8255 in three modes, mode 0, mode 1 and mode 2. So in order to operate the 8255 in mode 0 or mode 1 or mode 2, okay, we have to write control word in the control word register. Okay, let us see the control word. This control word is a 8-bit word. This 8-bit word. Among the 8 bits, first bit will be used to represent port C lower. Okay, if you want to operate the port C lower as input port, you have to set this bit as 1. In order to operate this port C lower as input port, we have to set this bit as 1. Otherwise, that is to be set with 0. This bit is used to represent port B. Port B, that port B, port C, port A can be used as input ports or output ports. Depending on the requirement, we set these ports. For example, if you want to operate port B as input port, you have to set this bit as 1. Otherwise, this bit, if you want to operate the port B as output port, this must be 0. Like that, this bit is used to represent mode of port B. As we discussed previously, in mode 0, yes, port A and port B, port C are operated as input ports. In mode 1, only port A and port B are operated as input output ports. In mode 2, only port A is used. Coming to the mode 0, if you want to operate this port 0 as mode 0, this bit is 0. If you want to operate the port B as in mode 1, it must be 1. This bit is used to represent port C upper. Port C lower and upper are two 4-bit ports. Whenever the 4-bit port is only required, we can have the port C upper and port C lower. Okay? This is to initialize port C upper. If you want to operate the port C upper as input port, you will set this bit as 1. If you want to operate the port C upper as output port, this must be 0. Like that, this bit is used to represent port A. That bit is used to represent port A. If you want to operate port A as input port, this is 1. If you want to operate port B as an output port, this is 0. And these two bits are used to represent mode of port A, to initialize mode of port A. Yes, port A can be used in all the three modes. Mode 0, port A can be used as input output port. In mode 1, port A can be used as input output with handshake. And in mode 2 is also port A is used. Okay, that is bidirectional IO is happened through the port A. So in order to select the mode of operation of port A, to operate port A in mode 0, both the bits are 0, 0. In order to operate in mode 1, these two are 0, 1. In order to operate in mode 2, okay, this will be X1. Like that, the mode of operation will be selected. This bit is always 1 to select IO mode. This D7 is always to be selected, mode of operation, that is IO mode or BSR mode. If it is 1, the control word is used to specify IO mode of 8255. So this bit must be always 1 in order to operate 8255 in IO mode. This is the control word of 8255. IO mode control word of 8255. Coming to the BSR mode of operation. BSR mode. This is one of the special mode. This is used whenever we want to interface any LEDs, like whenever we want to send some control signals over the port C lines. In order to send the control signals, sometimes we have to send the particular bit as 1, or we want to enable the signal, or we want to disable the signal. So individually we have to send those signals. To see here, this BSR mode is nothing but a bit set or reset mode. Bit set or reset mode. So through this mode, we can set or reset the individual bits of port C. This mode is only applicable for port C. This mode is used to set or reset the individual bits of port C. Yes, as we have seen already, port C has 8 bits, that is PC0 to PC7. So through this mode of operation, we can set or reset. For example, if you want to set the port C0 as 1, okay, we have to go through this control word of 8255. Like the individual bits. For example, if you want to reset the particular bits okay, of this port C, that can be done through this BSR mode. So let us see the format of control word of 8255 in the BSR mode. Yes, this is also an 8-bit mode. The first bit is used to represent whether the particular bit is to be set or reset. If you want to make, for example, the PC0 to PC7, that will be selected through these three bits. The 4C bits will be selected through these 3 bits. If 000, 4C bit 0 will be selected. If it is 001, 4C bit 1 will be selected. 010 means bit 2 will 4C bit 2, that is PC2 will be selected. 011 means PC3 will be selected. 100 means PC4 will be selected. 101 means PC5 will be selected. Like that, all the 8 bits will be selected through these 3 lines. To make that particular bit as set or reset, if you want to make that particular, for example, PC6 I have selected, that is 110. If you want to make that PC6 as 1, I have to set this bit as 1. Then only among the 8 bits, PC0 to PC7, that PC6 is set. Like that, we can set or reset the individual bits of port C. These 3 R's don't care, and this must be always 0 to select the BSR mode. Okay, this is the BSR mode controller format. Through this, we can set or reset all the 8 bits of port C. If we set this bit, the corresponding bit will be 1. If it is 0, the corresponding bit will be 0. These 3 R's don't care, and this is always 0 to specify that mode of operation is BSR mode. So these are the 2 control words that are used to specify the mode of operation of 8255. If you want to initialize 8255 in IO mode, we have to write the control word of IO mode. If you want to set or reset the individual bits of port C, this BSR mode will be used. After writing this control word, we have to store that control word in the control word register. Then only according to the requirement that 8255 is initialized for operation. See, let us understand the interfacing of 8255 with 8086 with some example. Okay, here in the example it is specified that interface an 8255 with 8086 microprocessor to work as an IO port. Initialize port A as output port and port B as input port and port C as output port, and port A address should be 0740. So we have to write an assembly language program to switch positions SW0 to SW7 which are connected at port B. Yes. Already specified that port B as an input port where the switches are connected. Yes, switches are the input devices. Okay, and the sensing pattern means the switch pattern is to be displayed on port A. Yes, where the port A as output port, to that 8 LEDs are connected. So the all switches, this according to the switch pattern which are connected at port B, it has to display on port A where the LEDs are connected. And while the port C lower displays the number of switches out of the total 8 switches. Yes, this is the problem. We have to interface the switches and the LEDs so that the switch pattern is to be displayed on port A and the number of on switches, the count is to be displayed on port C lower. The count is normally a BCD count. 4 lines of port C will be used to represent that BCD count. Okay. So in order to operate the ports like this, we have to write a control word. Yes, control word of IO mode, because here all the ports are defined as input or output ports. So we have to operate that 8255 in the IO mode. So we have to initialize all these ports according to the operation we have to write the control word. Let us see the control word of IO mode. So these are the 8 bits of control word. Okay. The first bit is used to represent port C, and this second bit is used to represent port B, and this third bit is used to represent mode of port B, and this fourth bit is used to represent port C output, as we already discussed. This fourth bit is used to represent port A, and these two bits are used to represent mode of port A, and this is always 1 for IO mode. This bit will represent IO mode. Let us initialize all these bits according to the given data. Okay. So in the data it is specified that port C as an output port. Okay. So port C is an output port. To operate the port as an output port, we must initialize the corresponding bit as 0. To act as an input port, we must initialize it as 1. So to operate as an output port, this bit is 0. This is port C upper. This is port C lower. Sorry, this is port C lower. This bit will represent port C upper. Anyhow, port C upper and lower comes under port C only. These bits, corresponding bits are 0, 0. This bit represents port B. Okay, port B has to be operated as input port. Input port means this must be 1. Port B as an input port. So if you observe, okay, all the ports are input output only. So the mode of operation is mode 0. Mode 0 port B means 0. Port A, and port, this is mode 0 operation. 0, 0 in case of port A mode 0 operation. Okay, simple input output. So both are operating mode 0. Okay, and this bit will be used to represent port A. Let us see what is port A. Port A is an output port. So this bit also must be 0. Okay, this is always 1 for initializing IO mode. So after initializing the bits, corresponding bits according to the statement, we have to write a control word. Okay, 1000 is nothing but a 8 in hexadecimal. 0010 is nothing but a 2. So what is this 82H? It is a control word that is used to control the 8255 operations. Yes, according to this control word, this 8255 will be operated. When it will be operated according to this control word, whenever we load this control word into the control word register address. So now we have to initialize the control word registers. We have to find out the control word register address. Then we have to send this control word into the control word register. So how this control word register address will be obtained? Based on the port A address. Yes, port A address is already given. It is 0740H. So what is the port A address? It is 0740H. Let us see. This is 0. This is 0. This is 7. This is 4. This is 00. So how the ports and control word register address will be selected? If we interface 8086 with this 8255, let us see. Let us take an example. A2 and A1 address lines are used to select ports and control word register. 00 means port A will be selected for operation. 01 means port B. 10 means port C will be selected. 11 means control word register will be selected. So let us see. 0740H is given as port A address. So we have to observe only this A2 and A1 address line. A2 and A1 address lines are 00. Yes, port A will be selected. In order to obtain the port B address, remaining bits are same except these A2 and A1 lines. If it is 01, port B will be selected. Yes, this is the port B address. If it is 10, port C address will be selected. If it is 11, control word register address will be obtained. So remaining address bits are same except this A2 and A1 lines. If we change this A2 and A1 lines, the corresponding port will be selected. So like that we have to obtain this control word register address. So what is the control word we got? That is 82H. That must be sent to the 0746 H address, that is the control word register address, then only the ports are initialized according to the requirement. Okay. Let us see the program to interface this 8255 to the 8086 to which LEDs and the switches are connected. So this is the diagram which is representing, okay, where the switches are connected to port B. Where the switches are connected to port B, these are the 8 switches connected to port B, and these are the 8 LEDs that are connected. These are the LEDs that are connected to port A, and where port C lower is used to display the count. Okay, so according to the requirement, read bar, IO read and IO write signals must be connected to read bar and write bar. Reset signal of 8086 is connected to reset, and A0 and A1 lines are connected with A1 and A2 of 8086 microprocessor, and D0 to D7 lines of microprocessor are connected to D0 to D7 lines of 8255 as we have seen in the block diagram, and only A2 and A1 lines are directly connected to select ports and control word register. What about the remaining lines from A15 and A0? Okay. As we have seen in the previous slide, all the address bits are used because the port A address is selected through 0740H. Total 16-bit address that is required to select the ports. Yes, processor has to send the entire address, but based on this A2 and A1 lines, the corresponding ports will be selected. So we have to use the remaining lines for selecting the chip through the address decoder. Yes, address decoder is the decoding logic that is used to select the ports through the chip selection. That will be connected to the chip selection. Here we can design any decoding logic. There it may be a linear address decoding, absolute decoding, and block decoding. Any one of these decoding circuits we can use to select the chip. We can design any decoding logic to select the chip. Okay, like that all the A0 to A3, A3 to A15 lines are connected to this NAND gates, so that this will be used to generate the active low signal so that the chip selection will be done. Okay, so let us see the program to display the switch pattern over the port A, and the count is to be displayed on the port A, port C. So coming in the example, so as we discussed previously, the control word must be initialized in the control word register first. Then only the ports will be initialized according to the requirement. Okay, what is the control word 82H? That 82H must be loaded in 0746H, and because it is the control word register address. So first of all, we have to initialize this 16-bit address in the DX register. Yes, 8086 has 4 registers, AX, general purpose registers, AX, BX, CX and DX. Among the 4 registers, DX is the only register that is used to initialize with some address whenever the processor is interfacing with 16-bit addressed IO ports. Okay, so we have to initialize DX with 0746, then we have to initialize AL with 82H, then AL, the data 82H must be loaded out with DX, out DX comma AL. Okay, so let us see the program step by step. Here I'll write the program. First, we have to initialize DX with control word register address, move AL with control word, then we have to out that AL into the DX. So now the ports will be initialized according to the control word. Okay, then we have to sense the switch pattern where the switches are connected at port B. So we have to read port B. So what is the port B address? If port A is 0740, port B becomes 0742. So we have to initialize port B 0742. Then we have to read the data, because where the switches are connected, switches can be on or off. According to that instruction will be used to read that DX data into the AL in AL comma DX. So after reading where the data is available in AL, it has to be displayed on output port A. So what is the port A address? Port A address will be 0740. So we have to out that AL data, whatever we have, that is the sensed pattern, that is the switched pattern, will be displayed on the DX. This part is over. Yes, we read the data from the switches. From the port B, we simply read the data. We have displayed that output in the port A. But what is the other thing we have to find out here? Number of on switches count we have to find out. That is to be displayed on the port C. So to get the on switch count, here I have taken one register with 00. That is BL I have used with 00, and I have initialized CH with 0808 because I know I have connected only 8 switches. I have to connect 8 switches. So total, to check the total number of switches, I have taken this CH with 8, okay, as a count. So I have used rotate left comma AL. What is there in the AL? AL is having the switches pattern. So for example, the switches are something like this. So switches will be enabled something like this. 8 switches. So what I am doing here, I am rotating all these bits to the left side. So whenever I perform rotate left operation, the leftmost bit, that is the MSB, will be rotated to the carry flag. So based on the status of the carry flag, I am going to know that whether the switch is closed or open, that is on or off. So after rotating left, okay, if I have the carry flag is 1, I can say that the switch is on. If I get the carry flag is 0, I can say that the switch is open. Like that, I can get the count of number of on switches. So for this, I am rotating the accumulator by 110. If no carry, I am simply saying that it has to go to the label 2. Okay. Otherwise, it has to increment BL. If no carry, then it has to go to label 2. Otherwise, what it has to do? It has to increment the BL. So it is saying initially BL is with 00. Now the BL becomes 1. So after checking that bit, it has to decrement the count. Yes. How many number of switches I have to check? Total 8 switches. So now my CH becomes 07. For example, if it checks the first bit. Okay, that if the CH is not 0, yes, we have to write this condition because this operation is to be repeated until all the 8 switches are checked. Okay, so if it is not 0, again it has to go to label 1. Okay, then again it has to rotate left. Again it has to rotate left, and carry flag will be checked. If carry flag is 1, BL count will be increased. So how many number of times that BL will be increased? 3 number of times. If the total 8 switches are checked, total how many number of on switches are there? 3 switches. So once this count is 0, it comes down. So what happened here? BL will be loaded with AL. What is the BL? BL is having on switch count. What is the on switch count? It is 3. This will be loaded into AL. Add, that is DX, 00H. Okay, because already port A will be initialized here. To get the port C address, we can initialize like this, move DX, 0744H, because this is the port C address where the on switch count is to be displayed. So like we can write move DX, 0740H, 44H, out DX, AL. In order to transfer something into the input output ports, we must have that particular data in the accumulator. No other register will be used. To initialize the ports, only DX register will be used to initialize. And to store something into the respective ports, we have to have the data in the accumulator only. No other register will be used. So like that, it will display the number of on switches count on the port C. So once the count is displayed, it becomes halt. So what we have to do here, we have to write the control word in the control word register. We have to get the switch pattern from port B to accumulator. Then we have to get the send the data from the accumulator to port A, and we have to check all the bits of this accumulator because we have to get the on switches count. Once the on switches count is there in the BL register, that must be transferred to the accumulator. Then it has to be displayed on the port C, so that the process that 8255 can be used to interface this input or output devices with the 8086 microprocessor, so that the corresponding operation needs to be will be taken place. So coming to the applications of this 8255, this 8255 can be used in industrial control systems, sensor and actuator control, automated test equipment, data acquisition systems, robotics, and the home automation also. Whenever the processor is to be interfaced with the input-output devices, that must be interfaced with this 8255 like devices, because the processor does not have any on-chip ports. It always depends on the 8255. So coming to the advantages, yes, it has high flexibility, simple interface, and wide compatibility, and it has enhanced speed also. So there are some drawbacks too. It has limited scalability, and the power consumption is high. It always the depend on the microprocessor, because microprocessor has to send control signals to the 8255 so that it will be operated according to that. Has somewhat complex in initialization also. So these are some advantages and the disadvantages of 8255. Thank you.